welcome to the session today on Mars. So we're going to take a trip to the next planet out from the Earth. So guys, let's go ahead and start talking about Mars. Probably one of my favorite pictures of Mars, looking at Elephant Rock with Mars sitting down there underneath that. It will be very bright in the sky, and it will go ahead and show up as a kind of a reddish color. And if you guys are familiar with the night sky and you go out there, you can definitely tell that you're seeing something different because you're going to know the sky and there's this bright red thing there that's not normally there. And so please make sure that you are checking your skymaps.com, and it will go ahead and tell you whether you have the planets out or not. This one, of course, you happen to see Mars. So now Mars is a red planet. It's named after the Roman god of war. But again, as we've talked, in a number of cultures, you're going to have different names for the same object because of that culture. We tend to, like I said, go ahead and use the Romans and the Greeks. And so from that standpoint, then that red looks like blood. And so we're talking about the god of war. It certainly is one of the planets known since ancient times. And it's also going to appear very red due to the fact that you have a lot of iron oxide in that crust. Now, periodically, Mars is going to get relatively close to the Earth. And again, relative is, again, a relative term. It's been a couple of years since it was real close. And so when it's that close, you can really do some nice observations. And that, those other decimal points are determined by the eccentricity and the positions and et cetera of both Mars and then the Earth itself. And like I said, when it's relatively close to us, or if you have a really good telescope, then it's certainly able to observe and show kind of vague surface details when viewed through a telescope. And if you ever have a chance, you definitely want to go out and look at Mars through a telescope. Now, Mars is further out from we are, because it's the fourth planet out. And Mars has always held this fascination for really a number of people. And I think it's because when you look at Mars and you observe Mars over a period of time, you get these seasonal changes, and some of them are real, some of them are perceived changes. But it looks like there are surface features that do change over the seasons. And so if we look at that and we're here on the Earth and we see seasonal changes that occur here on the Earth, then you make this really large leap of faith that, well, okay, there's life here and we have seasons and we see those changes. And so therefore on Mars, you see those changes as well. So, hey, there's got to be life there. And so there were a number of people that, certainly believed and firmly believed that there was life on Mars. And one of them was Percival Lowell, who went ahead and actually set up an observatory simply designed to go ahead and observe Mars. And not only did he look at the observatory and build the observatory and have that telescope available to him, he firmly believed that life existed on Mars. And so he went out and talked lots and lots and lots of places. And so he wrote about the fact that there were Martians living on Mars. He talked about it. There's a number of people, if you go back in the late 1800s and early 1900s, Nikola Tesla, think of the Tesla coil, those kinds of things, and a lot of others who claimed, and in some cases some reputable people, claimed that they certainly had contact with Mars. I'm not exactly sure what they actually had contact with, but boy, in their mind, they were certainly sure that it was Mars. And this is Percival Lowell at the Lowell Observatory, and he spent hours and hours and hours observing Mars. And we have some very nice descriptions as well as pictures from his observations. Now, this is Mars, and you can see that it is rotating, and you can see that there are very dark patches on there. And those dark patches do go ahead and change as the planet itself rotates. The other thing I want to point out is that you can also go ahead and see down there at the bottom, you can see what appears to be a white polar cap. And I think that's the other reason that a lot of people assumed that there might be Martians, is because you did have polar caps. Polar caps tend to contain ice, just like what our polar cap does, and therefore if we have ice and water, that certainly provides life here on the Earth, so possibly it does for Mars as well. Again, some really huge leaps of faith there. Same way you can see the opposite polar cap now, and you can see some of the surface features across Mars, and so it does tend to make you think that maybe something is going on. Not necessarily with life, but again, with the physical, geological structures that you have on Mars. And then you had this map that was produced, and this was produced in 1890 by a man with the last name of Schiaparelli, and he was observing Mars. And again, that idea that Mars had life on it, because when he looked at this, real or imaginary, what he saw were big long lines that seemed to come from the poles down to the equator. And he made them, notice, very, very straight. Okay? And so when he named them Canali, and when they were then translated, instead of coming in as channels, they came in as the word canal when they were translated into English. Well, canal tends to go ahead and imply there's some kind of intelligence behind that design or that building. And as you can see by this picture, you got all these nice little straight lines, and straight, nice parallel lines implies some kind of artificial intelligence that is going ahead and building those. Now, guys, when he looked at Mars, and it was at one of his closer approaches, and so he had a really, really, really good picture of Mars. It wasn't that he was lying when he looked at this and faking the drawings. It's just that when he looked at it, your mind tends to go ahead and put things together. And so sometimes you see things that you think are really there but really aren't. And so when other people later on with better telescopes went ahead and looked, they didn't see the same kinds of canals that he did. But we have really good detailed maps based on what he saw. Here's another kind of set of that with an actual planet right beside it. And you kind of see where some of that characteristics on the planet to the right show up then on the map to the left. I mean, you can see it's really easily up there in the top. You can see the polar caps. You can see that kind of real light reddish area down below on both of them. So we're seeing certain characteristics that are on the planet itself in his maps. It's just that idea of canals that were made by artificial intelligence because, they were an old dying civilization. They needed water, and the easiest place to get water was coming down from the poles. So it worked out as a kind of a really nice scenario. It just completely happened to be wrong. So like I said, that's more of that over-the-top thinking. So there was a lot of people then that were used to thinking about the idea that Mars was inhabited. And it was inhabited by civilizations that knew how to build canals, and they were able to tap the water in that polar cap. And so, again, they were like kind of an old civilization that was bringing the water down to where they needed it, more toward the equator. I thought you would like this picture. My cute little Martians. And by the way, guys, they had decided when they talked about Martians back in the late 1800s, early 1900s, that they were indeed green. How come they came up with a green? I'm not really sure. Probably would be an interesting thing to find out. But yeah, the Martians originally were green. You can see back there that they are indeed digging their canals. So we're going to talk about Mars as the way it really is. However, since Mars has certainly been in the forefront back with some incredibly large hoaxes that occurred in the early 1900s, I still want to go ahead and talk about how Mars is viewed in culture, as well as how it's viewed then in Hollywood and by those kinds of people. So if I look at Mars, we know that Mars has those two polar caps and those lines that I've talked about. Well, if you also look in the late 1800s, early 1900s, you have Edgar Rice Burroughs. Got to get my name straight there. And he wrote this wonderful collection of books that were set on Mars. And you can see one of them here called A Princess of Mars. And there's a number of them. And guys, if you have never read them, I would encourage you to pick up at least one of them. They're really good old-fashioned science fiction. And so you hear a little bit about Mars based on John Carter's perspective. So this one is The Princess of Mars. And so, again, the idea of this populated planet out there that possibly was like us. And here's another one, Marooned on Mars. Oh, and here I like this one. The Martians that are capturing the damsel in distress, Don't you like the eyes on that Martian? And then, of course, we have, as I alluded earlier in the early 1900s, H.G. Wells' The War of the Worlds. Now, this is the cover of his book, But the one I want to talk about is not the book, but more the radio broadcast. War of the Worlds was broadcast on October the 30th, in other words, right around Halloween. It was in 1938, and it was over the CBS radio networks. Guys, you might talk to your great-grandparents or your great-aunts or great-uncles, and some of them may have been alive during that time. And I know my mother was, and it was real interesting to listen to her description of what was going on in her mind. She was a young child when this was going on. It was directed and narrated by Orson Welles, and it was based, like I said, on the adaptation of The War of the Worlds by H.G. Wells. Now, it was presented, and it was meant to be, a Halloween joke, Halloween show. But it was presented as a series of simulated news bulletins, and they were doing it during a broadcast of the Mercury Theater on the Air program. And so you find, if you listen to it, and by the way, guys, I will have clips on it for you from Blackboard, because I do think it's interesting to take a listen to and see what it's like. So they went ahead and they stated in the beginning that it was nothing more than dramatization of H.G. Wells' book. But unfortunately, during the first 20 minutes of the program, there was another really popular program on the radio, and so a lot of people were listening to that. So when they turned over to what they knew was the Mercury Theater, then they had missed that first part. Also remember, guys, we're talking about in the early 1900s, you don't have the internet. You don't have that immediate connection to everything that's going on in the world. And so when the War of the Worlds came on, and it sounded like we really were breaking into what was going on with the dancing there at the show, boy, a lot of people ended up believing it. Basically, the story was about an alien invasion. It occurred at Grover's Mill in New Jersey. Basically, it starts with the introduction of the novel, and it describes the intentions of the aliens. And then it continues with this weather report about what was going on with Mars, and it looked like something was happening and things like that. And then it goes back to that dance band. Well, then, a few minutes later, you get this news bulletin about reports of this strange explosion on Mars, and it goes on from there. And, of course, these are what H.G. Wells envisioned as the invaders from Mars. And so they're running around destroying the Earth. And like I said, you didn't have that constant, yes, I know what's going on because all I have to do is, plug into the internet and it's there. And so I think a lot of people were certainly terrified. And they really thought that, something was happening. In fact, when it occurred, there really is a Grover's Mill, New Jersey, and so the sheriff was out there trying to figure out what was going on. Everybody was really confused. Well, there has been a couple of movies done by the War of the Worlds. One of them that was done not too long ago with Tom Cruise, and then certainly one done a number of years ago. Okay, and I can tell you that I'm a little bit biased toward the one that was done a number of years ago. If you have a chance to go ahead and view that one, do so. Use it as an assignment here, guys. Go look at the old War of the Worlds. Now, the other thing that tends to get very interesting, and people have this imagination that at times runs wild, is what you have here is one of the mountains or of the uplifted areas that you have on Mars. Well, a lot of people took this picture, even nowadays. This was taken early 2000. Go ahead and look at this picture, and if you put the light on it just right and if you highlight it a little bit, then it becomes a really big face on Mars. Is it the face of the creature on Mars? No. But again, people tend to use their imaginations when they don't know. And, I think people still want to try and believe that there is something else besides us out there. And so they kind of make these really wild leaps of fantasy. Well, guys, we're definitely going to talk about what's really going on Mars and not what's fantasy out there. But I can't go ahead and leave Creatures of Mars without talking about my favorite radio show when I was a kid. My favorite television show when I was a kid. And that was My Favorite Martian. If you ever have a chance to watch that, guys, go do it. Really cute little show. And you can see his little antennas will go up when he wants to use them, and then they'll go back down with this funky little noise. So, guys, I had to go ahead and at least end the part of Martians with My Favorite Martian. So now, let's talk about Mars in reality. It has a diameter about less than half that of the Earth. From its density, remember it's a terrestrial planet, it indicates that it's got a composition of silicates, think of sands, with a small metal core. There isn't any global magnetic field, although it's probably having one in the past, and it's just lost its heat and it's gone ahead. Because it is so small, it wasn't able to hold that, and so that probably went ahead and cooled off and solidified. Remember, guys, that we have a magnetic field because we have a liquid molten core that is rotating. So remember, everything we here on the Earth, we're going to compare with the other planets to see what's going on and what the differences are. Appears very red from space. I've gone ahead and mentioned that. The interesting thing about Mars, unlike any of the other planets, is when we're observing it, and you make very detailed observations over a number of years, it looks like it goes around the sun in one direction, and then it's going to appear to back up, and then it's going to start forward again. Well, this is called retrograde motion. Basically, it occurs because of the combined motion of the Earth and Mars and the fact that we're getting a little bit ahead of Mars as we're going around the sun, and so therefore we're looking back at Mars. But it's the only planet that does that. So really, guys, if we had looked at this, this would have been one more indication that the sun was at the center of the solar system and not the Earth, because you couldn't explain that retrograde motion if the Earth was at the center of the solar system. But you certainly can if you look at where the Earth is relative to the sun and then relative to Mars. And so it makes a lot more sense. And we now know that retrograde motion, Mars is really not backing up in the sky and then going forward again. It's just basically an optical illusion depending on where our position is relative to Mars. And this is a picture of that retrograde motion. You can see it kind of comes forward, backs up, and then heads forward again. And it's just when basically our two positions, one of them is in front of the other one. Now, just like every other terrestrial planet, the surface of Mars is going to have these continental highlands, and it's going to have lowlands as well as volcanoes. You know, it tends to be the same for Mercury, for Venus, and for Mars. This is a picture of Mars taken by one of the orbiters. You get this really great picture of Mars. You see this really big tectonic crack right as you look down. That's called the Valley of the Mariners. You see some volcanoes over there on the left, and then just kind of what the rest of Mars itself looks like. Notice that we are able to see all the way down to the surface, and we find out that Mars does have an extremely thin atmosphere. We also have this really large volcano called Olympus Mons, and I want you to take that volcano and I want you to basically set it on the state of Missouri. And it's the size of the state of Missouri. It's about 25 kilometers above the surface. That's about 15, 16 miles above the surface of Mars. So now think about that, guys. Mars is certainly less than half our size, and yet it has these huge volcanoes. Well, if you think about it, it doesn't have as much gravitational attraction because it is smaller, and so you can get these objects that grow much greater because that acceleration due to gravity or gravitational pull on Mars is about 38% of what it is on the Earth. Now, the other thing I want you to know about Olympus Mons is that the surface shows very little impact craters, which means that that volcano is probably relatively young. Now, guys, when I say relatively young, I mean I'm talking a billion years or so, you know, relative in terms of what's going on with the rest of the universe. And this is Olympus Mons, so imagine the state of Missouri right there, guys. And you can see that you have the main part of the caldera, and then you really don't have too many impact craters on the volcano itself, which is another reason why we think that volcano is relatively young, and it didn't, hasn't been real long since it went off and covered with lava. And if there had been impact craters there before, all of that was covered up by the lava. Different picture, kind of showing you more toward the lower end of Mars, again with the volcanoes. And yes, that is frost that you're seeing. So we find out that on Mars, we will have dew, we will have frost. So we can have ice, both water ice, H2O ice, as well as carbon dioxide ice. Atmosphere, we're going to find out, is basically carbon dioxide. Very, very thin, but basically carbon dioxide. Now remember, guys, Venus also had an atmosphere that was mostly carbon dioxide. And yet, look at the difference between Venus and Mars. Okay, same chemical, vastly different appearances. Southern part of Mars is going to consist of that heavily cratered, higher elevation terrain. The northern part, and I've got a picture later on that I'll show you that's color-coded so that you can see the difference, has got a lot of younger, lightly cratered volcanic plains, and we've got an average elevation of about 4 kilometers lower than the highlands. So it seems like the southern part of Mars is much higher in the landmass than what the northern part is. Originally, it was thought that maybe there was some kind of collision that caused that indentation. We now think that it was actually covered by an ocean. So there is a lot of indication that water at one time existed where it was actually in liquid form on the surface of Mars. And it was probably when Mars had a little bit thicker atmosphere, conditions way back in the beginning, but certainly evidence that at one time there was a lot more liquid water than what we see now. As I said, Mars has 2 polar caps, one at each pole, and they do so show seasonal changes. They get large in the winter and they go ahead and shrink in the summer, just the same way that ours do. Composed of frozen carbon dioxide, dry ice, and then frozen water, frozen H2O. Another picture showing you one of the southern polar caps and some more of just the terrain itself of Mars. You can see some frost on here, some clouds on here, more volcanoes. Again, that polar cap, this is probably more in the winter. So now let's talk about Martian weather. We do have seasons. The axis is tilted. So remember, we have seasons because of the tilt of our axis. Mars has seasons because it's tilted about the same. And those temperatures are going to vary greatly over the surface, a lot due to the fact that we don't have an ocean. There's a really thin atmosphere. There are some clouds, and I've got some pictures of clouds here later on. But take the Earth. You've got the oceans. Take all the water away from the oceans. So you got the oceans, and then you've got the continents. Well, that's kind of what we see on Mars. And then put that atmosphere much, much thinner, and then put a few nice high clouds in the sky. We've got temperature ranging from summer to a maximum of about 70 degrees Fahrenheit to minus 220 degrees Fahrenheit. That 70 degrees Fahrenheit isn't bad. We could actually survive out there in terms of just temperature-wise. Certainly not from the atmosphere, but temperature-wise we could. I don't know about you guys, but I don't think I want to experience that negative 220 degrees Fahrenheit. Extremely cold. And like I said, during the winter, you're going to have water frost. You're going to have CO2 frost, again, because you've got that really low temperature present, and so it allows it to go ahead and come out of the atmosphere. And so these are just some pictures of showing some of that frost, that ice that goes ahead and forms on there. Here are some clouds, so we're looking down, and you're getting some clouds as well as then some of that ice then on the surface. And then we have surface winds. Normally, they're very low. They tend to be very moderate in speed. But at times, these things can become extremely strong. And not only can they become extremely strong, they are planet-sized storms at times. And these windstorms appear to change directions with the season. And so sometimes you'll have this massive planet-wide storm that covers everything up. In the opposite season, it'll go ahead and uncover everything. And this is kind of what I was talking about. Look at the dates on here, guys. This is June 26, 2001, and then September 4, 2001. Same area. Notice a huge difference in the appearance of the planet. So you've had this massive storm come in and brought all these winds, which then completely covered up the surface. We used to see these in the Earth during the Great Depression with the Dust Bowl and all the dust winds coming across. And then lately, we've seen them in Phoenix, Arizona, places like that, both Northern Hemisphere as well as like places in Australia where it just literally completely, you can see these storm clouds coming and all they are is dust and they completely cover everything. As I've said, the Martian soil consists of clays and a lot of iron oxide, and both of those tend to be a very reddish color. And we think a lot of that water that Mars originally had, number one, either left the system itself, because you don't have a real thin atmosphere. It's also from the sun. It's a smaller planet, so you've got an escape velocity that's lower, so those molecules can go ahead and escape. Or some of that rock then is all, excuse me, some of that water is also trapped in some of the rocks. Because we look at rocks, because guys, we have been to the surface of Mars. We've traveled on it, we've collected things, we've analyzed that data, we've looked at these rocks, and they do seem to show presence of water, both in the past as well as currently. And I'm going to show you some pictures later on where we have some very fresh, what appears to be water ice that is forming on the surface, and it's probably not going to stay very long at all. But at least we see that for a very short period of time. And if I said this was on the Earth, you wouldn't question me at all relative to looking at that as being gullies that the water has run down. Well, we're not on Earth, guys. We're on Mars, and yet we make the assumption that the same kinds of processes, geological processes that occurred on the Earth, occurred on Mars. Just another picture of Mars. This is up more toward the poles, and we're going to come back and talk about those black streaks when we start talking about dust devils, sorry, got to switch that around, and exactly how they formed and what's going on there. And that's one thing that we see on Mars is a little bit different than those water spouts and those dust devils that we see here on the Earth. Another area on Mars, you can kind of see we've got a crater-like, and it kind of looks like you might have some kind of indentations, maybe some ice, things like that in the center of that crater. This is up toward the poles. If you were here on the Earth, guys, that would look exactly like what you would expect to see where something had frozen over and then started kind of crackling as it was either cooling up or warming up or cooling down. Happy face on Mars. This really is there, guys. Just a nice natural phenomena that looks like a happy face. How do you like this one? Again, one of the natural formations on Mars, a nice big heart out there. Is there a big heart beating under that sand? Of course not. But again, you get these geological features that look like things that we're familiar with, and so we tend to put certain connotations on them. Now, Mars has certainly been visited. If you remember back in 1976, Viking 1 and Viking 2 landed on the surface of Mars. What the Viking mission did is it wanted to look at the surface. It wanted to see what the surface was like. It wanted to see what the atmosphere was like. And it wanted to test both the surface and the atmosphere for evidence of life. And since 1976, there have been lots of other missions to Mars. We've had missions in the late 1990s, 2000, all the way out. It's probably, like I said, one of the most visited and photographed places other than the Earth. However, we have two rovers that are there right now called Spirit and Opportunity, and they landed in 2004, and they have gone way, way, way beyond their projected lifetime. And we've also got several orbiters, not necessarily just in the United States, from a number of places that are also in orbit around Mars. And so you've got Spirit and Opportunity, and then you've got some of these orbiters that are sending back really high-resolution images from Mars. And so we're getting, this unprecedented look at what this planet looks like. And every time we come up with another picture, there's this incredible view and trying to figure out exactly what's going on. Contrary to popular myth, it was not an alien spaceship that crashed. It was a top-secret weather balloon. For those of you guys that are old enough to remember Roswell and Area 51, I thought you'd enjoy this one. Now, we also have this rock. Now, this rock is actually on the Earth. But by looking at the characteristic elements and the percent composition in this rock, we can tell that this rock was actually from Mars. And so the first question is, how do we get a rock like this, meteorite, that we found in the Antarctic? Either the Antarctic or the Arctic, I'm not sure which one. Boy, the Arctic and the Antarctic are really nice places to look for meteorites because there's no weathering and erosion up there. So if you start digging down and you find these rocks, go ahead and collect them You come back and you look at them and you analyze them and try and figure out what's going on. Are they from the asteroid belt, in which case we're looking at primitive material? In this case, like I said, it's from Mars based on that chemical composition and the percent mass. So, as I said, how did this sucker get here? Well, if you have an explosion on Mars, such like a volcano or something that goes off, and we know that we've had active volcanoes on Mars in the past, that rock gets kicked up. Mars doesn't have a lot, it has an escape velocity that's relatively low, and so if this rock has enough energy, it gets kicked out of the orbit toward Mars and heads in toward the sun, or whatever direction it may head. And eventually, if it's heading toward the sun, it runs into us, and if it gets close enough to the Earth's gravitational field, it gets pulled down, and so then we are able to pick it up. Now, they went ahead and had this rock, cut it open, and that's what they found. Now, I don't know about you, but the question is that a fossilized life? Is that some kind of chemical reaction? Is that just some kind of, weird little natural phenomena? We're not sure. It certainly looks like it's bacteria. So the evidence seems to suggest, along with what we are learning about Mars and the fact that Mars at one time had a lot more water than what it has now, that it had a lot larger atmosphere, much thicker atmosphere than what it does now, that possibly there was at least microbial life in the past on Mars. We're going to be able to prove that? Probably not. Number one, we're going to have to be there, see if it's still living there, but at least it's seeming to suggest that the possibilities exist. So let's talk about those basic characteristics of Mars. The year is about 1.83 Earth years, basically the time to go ahead and orbit the sun. Its day is about the same as the Earth day, about 1.03 Earth days. And remember, that's a time to go ahead and rotate on its axis. Like I said, tilted essentially the same as what the Earth is, just a little bit more. But that means it does indeed have very distinct seasons. Has a relatively large eccentricity for the planets. And again, we've got that maximum minimum temperature range there. Surface pressure, notice guys, we've got an average of only 0.6 atmospheres. So that surface pressure is not very great at all. And so that's another reason you can have these really large geological structures, is because you don't have to push against the type of atmosphere that we have here on the Earth. Composition, notice most of that is carbon dioxide, about 96%. You got about 2.7% nitrogen, about 1.6% argon, and basically 1% of everything else. It's basically carbon dioxide. Now remember, guys, we have a lot of nitrogen in our atmosphere. It's about 80%. Mars is about 3%. Again, vastly different. Atmosphere also tends to be a little dusty, which accounts for that nice red color of Mars. Although in some places it also looks very kind of butterscotch as opposed to red. And so there's something going on then with the surface there and the chemical composition, things like that. Now, claims have been made with scientists that have gone ahead and studied Mars, is that they have observed and have measured methane in the atmosphere. Well, methane is an indication that, number one, you might have a volcano going off. Most of our methane on the Earth is produced from cows, that little life issue. So methane tends to break down in about 340 years. So if we're observing methane and we're measuring methane in the atmosphere, something has to be producing it. Again, exactly what that is, not sure. Certainly is less dense than the Earth. Take the land mass of the Earth without the ocean, and you get the size of what's going on with Mars. Gravity is about 38% of the Earth. We have seen meteors and auroras on Mars, so those do not seem to be any different on Mars than what they are on the Earth. And actually, every other planet that we have out there in the solar system, if there's an atmosphere at all. Like I said, we talked about this, those nice plains that are flattened, possibly at this point was an old ocean. And then, we have those uplifted lands then in the southern hemisphere. Said probably there's more and more indication as we look at some of the evidence that we gather from Mars that Mars was not actually struck by a Pluto-sized object, but then maybe it was just natural geological formation and then an ocean there. But we're still not sure. I mean, there's still a lot of work to do in planetary geology. And that's probably one of the biggest areas of astronomy right now, is looking at that planetary geology. We've talked about that. I want to go ahead and go a little bit to some of the pictures of Mars, because I would like to give you a feel for what Mars looks like. Here's just a picture of the polar caps. Now, we do find that there are, and by the way, guys, this is not a picture from Mars. Although we do have pictures taken from Mars that do show these, this one happens to be an artist's conception. That during the fall and during the spring, up by the poles, as you're getting that melting or freezing, you tend to get thinner areas on the ice as it goes ahead and breaks through, and then the surface below is heated, and so you get these geysers as you're getting the transition between summer and winter. Like I said, even though this is an artist's conception, we have pictures of this actually occurring on Mars. It's up toward one of the polar caps. You can kind of see where it's starting to melt. So these are the areas that you might see those geysers. They don't last very long, only a couple of months, and then they're gone. But they do reappear as those seasons begin changing. You know exactly what's going on here. We're up toward the ice caps. Not exactly sure what's causing these. Same way, we're looking at the polar caps here. And some of those are really nice, neat circles. Exactly what the mechanism that's causing that, don't know. So we do definitely get areas that have been uplifted. You can kind of, you'd almost think this was on the Earth. You certainly see those little gullies that are coming down, things like that. Again, up toward the polar caps. Here's another one where you're looking straight down on those polar caps, and you're really starting to see where that ice is getting thin, and that's what those little dark spots are. That's where the ice then has melted. But if you look at that, a lot of these do not look all that different from what you would see here on the Earth. So it's nice to think that, yes, the mechanisms that we observe on the Earth account for the same types of mechanisms that we see on Mars, with adjustments made for the atmosphere, for the size of Mars, for the fact that there's no water on there, things like that. Now, probably one of the big questions is there water on Mars? We certainly know there's water in the form of the ices that we see both at the poles as well as what we see on the surface when it freezes. We certainly know that it's solid carbon dioxide, dry ice. It's also ice as in water ice. We also know that it's buried in the soil as ice, and that was sampled by one of the Phoenix landers in 2008. If we look elsewhere, we can possibly see that as flowing water that's going to freeze, because remember, guys, we have an atmosphere of about 0.6 of what we have here on the Earth. And so even if there was liquid water on the surface, because the pressure isn't great enough, that water is going to boil away almost immediately, or it's going to go ahead and freeze, depending on where it is and what the temperature is. So we're never going to get very much flowing water simply because of the conditions itself. So, is water found on Mars? So like I said, there is a lot of evidence that Mars had a much wetter past. We've got large quantities of this water that's thought to be trapped underneath the crust. We now have enough landers on there. We've sampled. That water seems to be there. The other thing that we have sampled are the rocks, and there are certain minerals that have been detected in the rocks that can only form in the presence of water or are deposited by water. And so because we see those, and we see them here on the Earth undergoing that same kind of mechanism, we tend to think, okay, that's what's going on Mars. Hematite, which is what this is, we find these things. They are certainly evidence of water. In some cases, running water. Now, if I go and I just look at part of Mars, and I find Mars has incredible sand dunes. And those sand dunes will shift during the season, and you'll be able to see how they change. If it wasn't blue, guys, then you might think that's something out in the desert. Okay, now in 2005, we did think we saw water that was on the surface of one of the little gullies. And that shows it on the right there. You can see that in August 1999, it wasn't there. It was in September 2005. So did something happen that you had some kind of seismic event or something that let the water flow out that was trapped under the soils, and then it flowed down the little gully and immediately went ahead and froze? And so what we see is a presence of ice, and the fact that it's still so shiny is because it's very new ice. Now, let's talk about the geology of Mars. One time, it seems like Mars did have a magnetic field, which means it did have a liquid core, liquid molten core, probably metallic. Yeah, it's not there now. And again, it's probably because Mars was so small and it simply went ahead and wasn't able to hold its heat. We think the surface appears to be composed of basalt rock, which is basically what we would find like under the ocean, only enriched with some silicates, that sand-like material, glass-like material. Surface is covered by a really fine-grained iron oxide, which we've talked about, that gives it a nice red color. Core is probably iron with about 15% sulfur mixed in. You know, maybe partially liquid, but we certainly don't see any kind of magnetic field now. Like I said, although it certainly indicated it was one in the past. The crust on Mars tends to be a little bit thicker than the crust on Earth based on some of the measurements that have been made. And soils of Mars are a little bit more alkaline, about 7.3. They do seem to contain the nutrients that are necessary for life, which also goes back to that, you know, what are the possibilities? But one of the big problems is, since we never went ahead and had that atmosphere stay around, you never had oxygen in the atmosphere, we were never able to actually go ahead and come up with an ozone layer on Mars. Well, guys, think about what our ozone layer did on the Earth. That ozone layer protected us from those really high ultraviolet radiation that would make it to the surface if it wasn't for the ozone layer. So the problem is, even if Mars had life at one time, because of all those really high energetic ultraviolet rays that made it to the surface, there's a good chance probably a lot of that life didn't have a chance, because it would have gone ahead and killed it. I mean, imagine what would happen, you know, if I put you in a, you know, an oven and I baked you for a really long period of time. It's not good. Okay, so we also know that liquid water can't exist simply because of that pressure, as we've talked about before. I'm going to skip these. I'll go ahead and put these on Blackboard because I want to get to some pictures of Mars, some more pictures of Mars before we finish, and I'm running out of time. This is Mars just kind of laid out. You can see several volcanoes on there. On the northern part, you see those lands that are a little bit lower, southern part a little bit uplifted. Now, here's that diagram, that false color that I was showing you. Southern hemisphere tends to be uplifted, so probably lava from underneath that's coming up that just literally lifted everything up. Probably a lot like why we have the Ozark Plateau. The Ozark Plateau has been uplifted because of magma coming up and pushing from below. And then the northern area, you see those very lower areas, and so we think there's a good chance at one time that was an ocean. I'm going to skip that. Just some more pictures of Mars. Talked about Olympus Mons. And there it is covered with frost. And if I look down at that, I mean, I definitely see what appears to be cliffs, valleys, things like that. Now, let's talk about the Valley of the Mariners. Valley of the Mariners are a tectonic feature, which basically is a fault line, about 4,000 kilometers long and up to about 7 kilometers in depth. Okay, guys, don't worry about that. What I want you to think of is think LA, so Los Angeles to Washington, D.C. So I want you to think of a big tectonic crack sitting right there in the middle of the United States that goes from Los Angeles all the way up to New York or Washington, D.C. We think what happened is that crust couldn't handle the stress. It's a fault line. Think about fault lines. And that crust literally collapsed, forming the valley. And this is the Valley of the Mariners. And it's the picture I showed you earlier, and you can see those 3 little volcanoes, which, by the way, guys, there's spot 1, spot 2, and spot 3. Nothing really exciting about their name. But literally, this size, you could put the United States on there, which means that makes our Grand Canyon one of those little tributaries that comes into the Valley of the Mariners. Now, guys, this is obviously not a photograph on the surface of Mars, because you see those 2 little astronauts up there with a lander or a rover. Okay, but this is an artist's conception based on the data they've collected from the Valley of the Mariners. And so you can see, this thing is huge, running across the surface of Mars. And it's just basically where you had the crust was not able to support then itself, and it just literally fell through and cracked apart. This, however, is the Valley of the Mariners. And there are some really cool software programs, which I will have on Blackboard for you, that you can fly down through the Valley of the Mariners, which is kind of cool. Now, we have something, too, called the Seven Sisters. And they think that these are probably cave entrances on Mars. And because they're as deep as what they are and the light doesn't reach them, then we think there's probably water at the bottom of that. And so is there water? Is it liquid? Is it solid? Because you have life there. All those things that it would be wonderful to be able to go to and experiment with. Are we going to go to Mars? I don't know. It would be nice, and I would certainly volunteer. These are the Seven Sisters, and you can see that they're very, very dark because you're looking down then in a shadow. And so the sunlight never reaches them. Now, like I said, Mars is the most visited planet in the solar system. We've got lots and lots of people that have, in countries that have sent landers and orbiters, things like that. But as with the moon and any other planet that we try and visit, no country can go ahead and claim that planet. So these are the current missions to Mars. We've got Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter. We've got the landers. We've got Spirit and Opportunity. We've got the Phoenix landers. There were certainly missions that are no longer working. First successful flyby was by Mariner 4. And again, I'll go ahead and put that on Blackboard so that you kind of have a list, because I think it's important to look at the history of what we have been doing. Ooh, is that going to get swatted by a fly swatter? Okay, so let's go look at Mars. As we look at this, I want you to look at the soils and find it doesn't look a whole lot different than what we're talking about within a desert. Now, this is the way that one of the landers landed. They went ahead and it parachuted into, or went ahead and went into the atmosphere. Then basically big rubber balls came out and it bounced along. And then it opened up and the rover then went off. This is actually a picture of Mars. And no, there wasn't somebody there taking that picture. One of the things that first came up was a camera that was able then to go ahead and show what was happening to one of the rovers. And there you see one of the rovers leaving. And I don't know whether that one is Spirit or Opportunity. And just look at the surface. You definitely see those red clays. And there's the path of either Spirit or Opportunity as it's taken off and wandering. Just going through some pictures of Mars. Now here we found some rocks that had a little bit of blue tinge to them. And I've talked about this on Blackboard and what the chemicals are that might be making up this. So make sure you check Blackboard, guys. Some more of that blue rock. Those are the path that either Spirit or Opportunity, one of the rovers, took as it went around one of the craters on Mars. That's just looking across the crater. And this is that same crater looking down from one of the orbiters. And you can just barely see up there on the upper left where the paths are, where one of the rovers has gone. And that's ice that you see down there in the bottom of that crater. More sand dunes on Mars. I don't know, to me it kind of looks like an alien environment out there, a really abstract painting. And then I want to get to this picture right here. And we'll finish with this picture. This is a picture up toward the polar caps. And I don't know whether it's a southern polar cap or whether it's the northern polar caps. But either way, you are going to get these dust devils that I referred to before. And remember, I said that they weren't exactly like what they are here on the Earth. Well, when these things form, and on Blackboard, guys, I've got a link where you can see these things forming on Mars, and actually there's a number of them, and you can see them moving across. And when they move across, they look like they're sparking down at the bottom. Well, our dust devils don't do that. But they think that what's happening when these dust devils are forming, there's some kind of electrical discharge within the dust devil itself where it interacts within the surface, and it kind of makes a black mark. And so every one of those black marks that you see on there are from these dust devils that formed and electrically then interacted with the surface and shot sparks up and this kind of light that came off of it. Why it's doing that, we're not sure. Like I said, guys, there are still so many things. And the more we get up there and the more we look around, the more we have that we don't know. So if you want to go into planetary geology, guys, hey, that is a wonderful thing to do right now. One of the things that NASA is looking at, certainly not in the near future, but is to going to Mars and looking at what happens if we send humans to Mars. And can we have a colony there? What are we going to find? Things like that. But I want to end Mars with my favorite sitcom, was My Favorite Martian. And I know that some of you guys are a lot younger than I am, so you may never have gotten a chance to see My Favorite Martian, the original one. So if you do, guys, I'd look it up on Netflix, go back and enjoy it and remember what's going on with Mars. So with that, guys, we'll do the gas planets next. Talk to you then.